So today, we're going to break down one of the most audacious tech upgrades you've probably ever heard of, how the entire Ethereum network swapped its engine mid-flight, shifting from a system of brutal competition to one of collective security. But before we get into how they did it, we've got to start with this really fundamental question that every single cryptocurrency has to answer. In a network that's spread all over the globe with thousands of people who don't know or trust each other, how on earth do you get everyone to agree on what's true without a CEO or a central bank to call the shots? Right. So this is what the experts call the problem of consensus. And for years, the solution wasn't about, cooperation. Nope. It was all about raw, brute force computational power. Think of it like this. The answer was this massive global digital race, a system where powerful computers all over the world were just battling it out 24/7 for the right to update the network and claim a prize. And that competition, well, it had a name you've probably heard thrown around before, a system used by both Bitcoin and, for a long time, Ethereum, proof of work. The whole concept is really right there in the name. You have these miners using incredibly powerful computers to prove they've done a huge amount of computational work. How? By being the first to solve a really difficult math puzzle. The winner gets to add the next block of transactions to the chain, and for their effort, they earn some brand new ETH as a reward. Whoa, okay, so this diagram looks pretty intense, right? This is Ethereum's specific puzzle. It was called ETH hash. But you don't need to be a cryptographer here. The only thing you really need to get is the core principle. It was designed to be incredibly hard to solve, but super, super easy for everyone else on the network to check if the answer was right. So to put it really simply, here's what was happening. A miner would download this massive file, mix it all up with the latest transaction data, and then just guess. Over and over and over again, trillions of times a second. They were hoping to get a lucky result, a number that was below a certain target. Finding that one lucky number was the proof that they did the work. And look, the thing is, this system worked. It kept Ethereum secure for years. But, and this is a huge but, all of that computational guessing consumed a staggering amount of electricity. I mean, we are talking about a level of energy use comparable to entire countries. So this massive energy problem, that was the real catalyst. It pushed the Ethereum community to attempt something that had never been done before, a complete operational overhaul, live, without ever shutting the network down. This incredible event was called the Merge. Think about that. For over 7 years, this energy-hungry system was just how Ethereum operated. But on one specific day, September 15th, 2022, after years of planning by hundreds of developers, the entire network changed course in a single moment. The developers had this amazing analogy for it. They said it was like swapping the engine of an airplane while it was still flying. And that's basically what happened. The old proof-of-work chain, with all of its history, just seamlessly merged with a brand new chain running on a completely different system.
And that new engine, the one that's powering Ethereum right now, that's called proof of stake.
So instead of proving you've done all this computational work, you now have to prove you have skin in the game. It's not a race to see who can burn the most electricity anymore. It's much more like putting down a security deposit. These new participants, called validators, lock up their own money to vouch for the network's integrity. Here's the breakdown of how it works. First, to even participate, you have to deposit at least 32 ETH. From this giant pool of validators, individuals are then randomly chosen to create the next block. If you do your job honestly, you earn a reward. Simple enough. But, and here's the kicker, if you try to cheat the system, the network literally destroys or slashes a portion of your staked ETH. The whole thing is designed so honesty is profitable and cheating is really expensive. So how does the network pick who gets to do the work? Well, you can think of it like a constant digital lottery. Every 12 seconds, that's it, just 12 seconds, a new group of validators is randomly selected into committees to propose and check new blocks. This constant reshuffling ensures no single group can ever gain control of the network. All right, let's just put these two side by side so it's crystal clear. With proof of work, security came from computing power. With proof of stake, it comes from an economic stake. Miners competed, validators are chosen, and of course, the big one, massive energy consumption becomes incredible energy efficiency. Okay, so we've spent a lot of time on the how, the nitty-gritty mechanics that keep this whole thing running securely. But what does this technology actually do? What is it all for? At its heart, Ethereum is a platform for creating and managing digital assets, or tokens, and there are basically two main flavors. On the left, you've got fungible tokens, where each unit is identical and interchangeable, just like a dollar bill or the ETH coin itself. On the right, you've got non-fungible tokens, or NFTs, where each token is totally unique and represents ownership of a one-of-a-kind item, like a piece of digital art. And the magic that makes all of this possible is something called a smart contract. Honestly, the best analogy is a superpowered vending machine. You put your money in and make a selection. That's the if condition. Then the machine automatically dispenses your item. That's the then action. It's a contract that just executes itself based on programmed rules. No middleman required. The process is simple but incredibly powerful. First, the rules of the agreement are written in code and published to the blockchain, where they become permanent and totally transparent. Second, a specific trigger, like a payment being received, activates the contract. And third, the code just automatically enforces the outcome. But, Ethereum's journey is far from over. And before we look at the next great challenge, it's worth just taking a moment to appreciate the sheer scale of the problem the merge just solved. 99%. Let that sink in for a second. By switching to proof of stake, Ethereum cut its energy use by an estimated 99%. This was one of the single most significant decarbonization events in the history of technology. So with that monster of a problem solved, a new one came into focus. You see, blockchains face this thing known as the trilemma. The idea is that a network can usually be great at two out of these three things: being decentralized, being secure, and being fast. But achieving all three at once is the ultimate challenge. The merge dramatically improved Ethereum's security and sustainability, but the quest to make it faster and cheaper for everyone to use, that's the scalability piece of the puzzle, is the next great challenge. Which leaves us all with the ultimate question for the future of this tech: security, speed, or decentralization. Can you ever truly have it all?